See some more in the hallway. Hi, Rally. Great, thanks. Appreciate it. Yeah. Or do you want to go find her? Yeah. Okay. Thanks. Right. Okay. We're recording. Um, so I could read this entire blurb stuff, but the bottom line is that we used to graph things in 2 dimensions. Now we're going to graph things in 3 dimensions. I know it's going to be kind of weird. I know it's going to be a little strange. So what I want you guys to do is if you go to Desmos, go to desmos.com/3D. So they're 3D graphings and beta testing right now. So let's see. It's actually pretty good. I tested this morning. So we're going to work on graphs in 3 dimensions and equations in 3 dimensions. And then we're going to move into a new topic called matrices later in this unit. So let me go to desmos.com/3D. Desmos.
How hard is this?
How hard is this unit? I don't know. I don't think it's that hard. It's pretty short. We're actually going to test again before we leave for ski week. So in a couple weeks, we're going to test again. Yep. No, it's well, it starts at the end of 2 weeks from now.
Or just
Right, on February 13th. Okay, so here's what I want you guys to type. Hopefully everyone's in the same place. We're all here. All right. So here's let's do this. Let's do x plus y plus z equals 1. Now it's gonna look a little strange. I know it looks like a triangle. Let me actually turn this off for a moment.
I don't know different years. Can you show it again?
That's because you probably zoomed in or zoomed out.
I don't see the hexagon. Mine looks like that. Wow.
X plus y plus z equals 1.
This. Yeah, I got it.
Try rotating it.
Wait, yeah.
Should be a triangle.
It's definitely not a triangle mystery.
One.
We all have the same.
That
Could be hypothesized.
X plus equals 1. I don't know what's.
going on.
I don't know what's going on. Try refreshing the screen.
What?
I don't know.
No. Want to play quicker so that.
True. But I wonder why mine looks different.
I got this one.
Hold on. Try it again.
By odds, best ones. Are you sure yours is a triangle?
No, why it's
The axes are different. Should I change that? It's not gonna do anything.
no. I don't know.
It's just like every time.
Turn that off.
Mister, are you sure yours is a triangle? Maybe you should check it out.
Let's try a different equation, guys. I don't know what's going on.
Well,
Let's try different equations. Let's do this. Let's do 2x plus 3y plus z equals 6. Okay, this is gonna be a little off or tricky. Yeah, I do too. Okay. So let me draw this on the board. You know what? Let me do this, guys. Here, this is kind of a fail here. It's okay. All right, let's do this first. Okay, let's call this x, and we'll call this z. Okay. So let's draw on the notes. Let's call it x, and let's call that z. Yeah, I don't know what's going on. This is why it's in beta testing. Okay, so and let's call this y. Okay. Oh. Okay, so forget about this Desmos thing. This is not quite working the way I wanted to. So what I just drew is called a three-dimensional plane. I'm gonna draw 6 tick marks on each of these axes. So it's a little tricky.
How is that 3D?
Here's how it's 3D. The X and the Z.
Oh.
Imagine the X and Z are on the board. Imagine the Y is coming out of the board and going into the other classroom. Okay, so it's kind of like this. Gosh, I wish I had another.
Like later.
Just relax. I'm not gonna do too much crap for this. It's like this, guys.
Oh.
Okay, that's how this is like. So think of the green as Z, the red as X, and the Y as black. So you're graphing something in 3 dimensions. That's what we're doing. Now, if I were to graph this equation here, here's how you want to graph it. Oh, thanks. You want to find the intercepts. Okay. Now, if you think about it, what if Y and Z are 0? What would X equal? Y and Z are both 0 for this equation I just put. Go ahead. 3, perfect. Thank you, Ellie. So yeah, so 3 would be right here. Now, what if X and Y are both 0? If X is 0 and Y is 0, what's Z gonna equal? 6. Thank you, Sora. So that's 6. That's right here. And lastly, what if Y and Z are both, sorry, X and Z are both 0? Correct. 2. Y is 2. Correct. So you have a dot right here. So the way this looks, you connect these. So the equation is a plane, not a line. That's a key takeaway. Even though this Desmos demonstration sucks, I was hoping to do better for you guys. I apologize about that. But the way you graph in 3 dimensions, if you're given an equation with a third coordinate, okay, so guys, let's focus please. Thanks. I know we're a little squirrely, but anyway. So if you have squirrely, slow.
Never.
What?
I've never been called squirrely.
What do squirrels act like? That's what you're being. Acting
Well, not quite, but guys, let's just focus, please. Thank you. Okay, so if you add a third coordinate, the best way to graph this in a 3-dimensional, it's not a plane, a 3-dimensional coordinate system, is find the intercepts, locate those on each of those 3 axes, and if you connect them, you form a triangle, which is a plane. So I know it's kind of weird, it's kind of abstract, but that's what's happening. But go back to the notes. Let's fill it out, and then
It's not a triangle.
I don't know. I don't
always be triangles.
Well, actually, technically, a plane goes on forever. So it's like a piece of paper. It's like if I took like kind of your paper. Well, so it's kind of like if I took this piece of paper on these axes,
Yeah.
and this piece of paper just expanded forever, like this way, that way, and up and down. So
Then it would still be a triangle. Just be
well, that'd be a cross section of your plane. That's all it would be. It'd be a portion of your plane. We just draw a triangle just so we have something that's finite. Let's just try typing different equations. Let's just move on because it's not really working well. Let's move on to right here. So I want to just wrap up the 3D graphing, and then let's talk about solving a 3-dimensional equation. That's what we want to do. So a point in 3D is represented as a point. A linear equation with 3 variables, where a, b, c, and d are constants, represents a plane. A line in 3D can be represented. Hold on, I actually did remember what this. By the intersection. I remember. of two planes. And when we have three linear equations, three variables, we can have a single point as an intersection. And that's what we're going to do in example 4. Or the system below. Hey, Reggie. Yeah, I'll go ahead.
What's the point of?
But that's when you have multiple,
Points.
but when you have multiple planes though, there's gonna be a place where they all meet up. And that's what we're trying to figure out. So one thing that actually, if I go back to Desmos one more time, this is gonna look kind of trippy. We're gonna plug this in Desmos because actually I do want to see what happens. But what if I did this? Okay, hopefully you guys get that. Do you guys get this if you type in z equals 5? If you change this z equals 5. Yeah, good. Okay, I do see Lois has that. That's good. If you, oh, that's because of just how your scale set up. So what does this mean? This means all z values are 5. X, Y can be whatever you want. So it's like a piece of paper that just goes on forever, but it's always 5 units away from the origin on the z-axis. So that's how you can think of it. You can think of it like that. But what we're trying to do is we're trying to find the intersection among all three of these equations. I mean, if I were to type in the other one just to see what happens. So see, I get negative x plus 2y. Negative x plus 2y plus z equals 10.
For D.
Mhm.
For three. When we have three linear equations with three variables, we can have a single point and then.
We can have a single point as an intersection. 2x minus 3y plus z equals 10. Okay, that looks absolutely crazy. But apparently we're trying to find where all these touch. And you can see why this is probably in a beta version because it's kind of hard to tell. They do touch somewhere. I think what's going to happen, if I were to extend this plane more this way and extend this more, well, it looks like they should be touching eventually. I think ultimately they are going to touch somewhere along the way. Yeah, that's just not really the best example. I think this diagram sucks. No, this Desmos, they need to do some work on it. But here's here. I know they kind of do a little bit, but let's solve it. So how do you think we're gonna solve it? How do you think I would solve the system? What process do you think we should use? This is the part I do care about. Because this part we are going to be spending a lot of time on this unit. Ellis, you have an idea?
Well, I think we can do that, how do you combine the new atom?
Elimination, we can do that. Or another technique that starts with an S. Substitution, yes, let's substitute. I think that's going to be a best way to approach it. For this particular case, sometimes elimination is better too, though. We'll see those cases when that's good. So if I substitute, I should get this, guys. Negative x plus 2y plus 15 equals 6. So negative x plus 2y equals negative 9. Also, let me switch colors for a bit of contrast. 2x minus 3y plus 5 equals 10. So 2x minus 3y equals 5. Okay, we have two equations and two variables. We do, right? Now, do you guys remember how to solve how solve this system? Lois, can you please focus, please? Thank you. I know you're not focused. I need you to focus. Thank you. So now you got two equations, two variables. What would I do next? Go ahead, Elise.
One, so, x, make it equal to x and substitute that.
Yes, excellent. Yes, that would be a great strategy. You could also do elimination again. Or no, we didn't do it first time. You could do elimination, but yeah, I would substitute. I like that. So we could do this, which becomes this. And then we're going to substitute into that equation right there. So before I get too carried away, I don't want to lose anybody. You guys see how I replace z with 5?
Yeah.
And I move the number to the other side, right? So I got negative x plus 2y equals -9. For this one, I get 2x minus 3y equals 5. Cool. I got this. I got this. Now here I'm isolating x, which is a good idea. You can do that. You move the 2y over, divide by -1, substitute. Now my substitute, I should be able to solve for y. So I'll switch to green. So 2 parentheses. What do I put inside the parentheses? 2y plus 9, exactly. So you get 4y plus 18 minus 3y equals 5. Y equals -13. If y equals -13, x should equal I think -17. Make sure I'm doing this right. Yeah. And then if x equals -17, y equals -13, of course z is 5. So my solution is going to be -17, comma -13, comma 5. So that point in 3 dimensions will satisfy all 3 equations. And the best way you could check it is to plug back in. So for number 5, just plug back in. You can check it out, and it will work itself out. So how can we check? You plug in the solution. That's how you can check your work. Okay. Questions on that one? Now, go ahead, Alcon. Yeah. No, go ahead.
Solution for.
You rise the order triple. You
Once
right?
we get to graph it,
Correct. Right.
It's like. You're trying to find the intersection.
We're not going to do that. That's too much. Yeah, that's a little too much. But actually, we're going to use a process called a matrix, where you're going to organize this into a rectangular arrangement of numbers. And that will be actually a very efficient way. We're going to use a graphic calculator next week to do that. Now, why do we care about this? We care about this because there are going to be word problems that will have 3 unknowns. And you need to make 3 equations of 3 unknowns. And you want to be able to solve that. Can you leave Adelaide alone, Lincoln?
Yeah.
Thanks. All right. Okay. Yeah. So we're gonna see some word problems like that will involve 3 unknowns. We have to make 3 equations. Doing algebraic is probably not gonna be the best way. Using something called a matrix will be the best option. We'll learn about matrices next week. One last thing we'll do before we do, you guys get a head start on the homework. Says consider a graph of x equals 4 for each of the following problems. Graph the solution in 1 dimension, graph it in 2 dimensions, graph it in 3 dimensions, and then we'll solve a system, then we're done. Okay, so let me show you each of these different techniques. So 1 dimension, 2 dimensions, 3 dimensions. So if you graph x equals 4 on a number line, it's pretty easy, right? That's it. How about in 2 dimensions? This is x. Do you remember how to graph x equals 4 on a 2-dimensional plane? Yep, there you go. And then in 3 dimensions, it'll look like this. One, two, three, 4. It's kind of weird.
So which one is Z like pretty much like diagonal one?
It's up to you actually. I usually make Z the going up and down and Y going in and out. It's up to you. It's your decision.
Like that.
It's gonna be so weird. Go ahead, Alexander. Yeah.
Sorry.
It's gonna be so weird. Go ahead, yeah.
A diagonal line is representing the third plane,
Correct,
3D model of
correct, right.
the 3 dimensions is, I'm just confused by the Z. And also, why are you switching, how can you switch Z and Y?
It's up to you. I could put a Y there, but see,
I know, but like, how can you do that?
I felt like it.
You can't do that.
It's just a
for, like,
variable.
And you want, it's up to you. Yeah. What I probably should have done, it'd been nice to actually bring like. Maybe I'll just point up here, like bring like 3 yardsticks and kind of set it up like that way. And then, yeah, I'll find those yardsticks. And then you kind of like have a sheet of paper at x equals 4, and that would be the graph of x equals 4. It's just essentially a plan. It's a crappy drawing.
No,
But seriously, we're not gonna really spend much more time on graphing of 3 dimensions. I just want to just introduce that. What I really care about is solving the system. That's what I care about. And so we're gonna do that right now. So we're gonna do solve one more system, and then you guys can work on homework. And homework's on the next page in your notes. All right, Link, can you come back to your desk, please? Yeah, can we leave John alone? All right, thanks. All right. All right. Now this one's a little. How much money are you making, man? Wow, really? All right. Can you buy us lunch tomorrow or Friday? Okay, or buy bagels. All right. So what do you guys think about this one here? This is gonna be a little tricky. You guys have ideas of how I can approach number 6? So you want to get z by itself in the third equation? That's a great idea. Thank you. I love that idea. Yeah, so here's what I would do. You could do elimination, but you might drive yourself nuts because there's so many variables. Personally, what I do is isolate one of the variables and isolate a variable that has a coefficient of 1 or -1. Therefore, you avoid fractions, right? Because if you get like x by itself in the third equation, good luck. Likewise with y. You can probably get x by itself in the first equation, and I will promise you that I will make it so that you can isolate one of the variables easily. So now what do? I'm going to call this equation 1 and equation 2. So you really want to be organized here. For equation 1, I'm going to rewrite like this: x plus 3y minus 5 parentheses equals 13. Equation 2, 4x plus 3y minus 5 parentheses equals 37. So what are you going to put inside the parentheses for each of these? Yep, 100%. Now you see where I'm going with this. I need to clean up each equation. I know it's a pain in the ass. I'll be honest, this is a total pain to do it this way. Once I show you the more efficient way, once we talk about matrices, we have to at least describe what a matrix is to you. I think we're going to do that on Friday. And then next week, we'll use matrices to solve these. Matrices are a lifesaver. It's like actually, sometimes you do have to deal with like 4 or 5 unknowns. Sometimes you do have to. And that will be a really efficient technique once we get there. But for now,
we'll have to do with 3 to 5 unknown in 3 dimensions.
Correct, right. So well, no, hold on. If you do have 5 unknowns, I'm not sure how that would look graphically, but
Yeah.
I'm not gonna go there. But the thing is that right now we're just solving a system of 3 equations, 3 variables, which yeah is a 3-dimensional system. But yeah, we have to clean it up. So let's go and clean it up. And this is where you can easily make careless mistakes. So let's be awfully careful here. If you clean up equation 1, so distribute the -5 and combine like terms, what do you guys get? So clean up equation 1, distribute the -5, combine like terms. Tell me what you guys get. Good, that's a good start. Keep going. Dude, you're on fire. Keep it up, man.
8y. 8y.
No, not 8y. You get -20, but move to the other side, you get 33. Yeah. Okay, next one should be negative. Not negative. 16x. Oh, that comes out kind of nice. Another -22y. Lucky us. Equals 57. Cool. Okay, would you do substitution again or elimination? Yes, I would not do substitution in this case. So you gotta be very flexible with your solving skills. Very, very flexible. So if I subtract these equations from each other, what happens when I subtract these equations from each other? What would I get? What's 11 minus 16? Yep. And of course, negative 22 minus negative 22 cancel. And this becomes, really? It came out like that? That's kind of weak.
-14.
No, negative 24. Hey, watch the language. Easy. It's okay. It's all right. Well, anyway, let's come out as an integer. Hold on, let me make sure we did this right. We made a mistake, guys. Got it. Okay. It wasn't 16x. What should it be? No. Actually, I said 16, so more confirmed with me, but I think we made the same mistake. I thought you said I thought you said 16. Did you say 16? Someone said 16. Did you say 16? Someone said 16. I thought I heard from here. Okay, sorry. Okay, you know, I'm hearing things. I'm being delusional. No, it's my delusion. I apologize. All right. Okay, it's 14x, so negative 3x. So x equals 8. Okay. Now, why did I do a double take? Because I do write these. Well, I didn't write this problem, but these problems are written so that things should come out nice and clean. That was not looking nice and clean. So I'm glad I caught it. X equals 8. Now, if x equals 8, we could solve for y by putting into either equation. Just be careful again. 88 minus 22y negative 22y equals trying to be really, really careful here. Don't mess this up. Yes, negative 55. So I think y will be 2.5. Think that's okay? Yeah. And then lastly, you can solve for z. 4 minus 2. Now, I'm going to show you a way the graph calculator can do this efficiently. There's a way the graph calculator can do this for you. Actually, I'm going to kind of teach you guys a little bit about matrices today, just so you see how that works. And then we'll be done for today. So z should equal negative 12, 2.5. I think it's 0.5. If I'm not mistaken. 16. Yeah, I think that should be right. Yeah, I think it's right. Let me double check the other ones. 8, 7.5, 15.5. Yeah. Okay. Really fast. Let's do this in the calculator, and then we're all done for today. So you guys have an app called Simultaneous Equation Solver. My calculator doesn't show that, so I'm just going to do something else instead.
On what?
All right, let me go and clear this.
Same.
Shoot, I don't have that app. Darn it. Okay, one thing you could do, which it's going to be kind of confusing at first, but we're going to do this often next week. You can create something called a matrix. In case you guys are curious how a lot of data is stored, like Amazon, for example, is probably one of the biggest places in the world that stores data. What you do is you type in all the coefficients. Alex, can you stop talking? Can't girl stop talking? Thanks. Let me finish talking. 1, 3, -5. And you guys just watch for now. I'm just gonna we'll do this in all its glory next week. Exactly. It's my random sayings. -5 and 1. What you do, it's gonna be weird. It's not gonna make any sense. If you raise this to -1 power and you make a new matrix that has 3 rows and 1 column, and you type in these numbers, this will get us the answer. So it didn't take me very long once I knew what I'm doing. Yep, those are the answers I got. This probably doesn't make any sense. Don't worry about it. We'll clear this up next week. I did want to show off, yes, 100%. No, what I really want to show off is the app, which I can't access, but you guys have on your calculator. Actually, I could walk around and show you guys how to do it in the calculator. So homework will be the following. It's on the next page. Actually, it might be my other folder here. Here we go. Let me pull it up. Oh, thanks, Reggie. Awesome. Thanks so much. Spring semester, unit 2, work. Classwork. Yes, student version. Okay, so homework will be this. So you see there's some practice on solving exponential equations, logs, exponential stuff. So a lot of like old stuff actually, and then some stuff on 3-dimensional graphing, and then solving a system, as you see here, and then just a learning log at the end. So that's the homework. It's on, and then there's extra practice. Don't worry about the extra practice. That's just if you really want it. You can probably save it for another time. Like, yeah, if you're really bored this weekend, you want to do 14 solving systems with 3 equations, 3 variables, go for it. It's right here. It's the 4th page of your notes. Okay.
Do we have
So
to?
she's solving 2 systems only. Was
We
that?
have to do a learning log.
Yeah, just do just a little something. I don't know. Yeah. Just write a little something. Yeah. Okay, so I'm all done, and you guys can use the rest of class. We have another, what, 15? Yeah, 14 minutes. Yeah, perfect. All right, so you guys can get head start on homework. I'll stop the recording.